Hello geometry students. Today we're going to be continuing our discussion of composite solids by taking a look at the surface areas. So please copy down the title as well as the objective. And our objective for the day will be to learn to describe composite solids, then calculate their surface areas. Now, for those of you that are paying attention, you may be wondering how come a part of our objective for today is to describe the composite solids when we already did the description of the composite solids when we were talking about volumes. But as you're going to see today, looking at the describing the shape as far as a surface area can actually be a little bit different than describing the composite solid as far as volume was concerned. Okay, so when calculating surface area of composite solids, we're going to employ some of the same ideas that we used with volumes. Okay, but as you're going to see, there are some new considerations that we're going to have to accept that they exist. And now we're going to use the same 5 composite solids that we did from the other day. You do not need to copy them down from this screen, but we are going to be looking at them one at a time, and you do need to copy them down again during this lesson as they appear on the screen one at a time, because we do have some new measurements and things going on with these shapes, so we don't want to be using the old shapes and the old measurements from yesterday. Okay, so we're going to take a look at the first figure. Please copy it down along with the measurements that are provided for you there in the diagram. As you are copying it down, let's see if we can figure out what the description of this shape would be and whether or not it has changed from our description the other day. Now, the other day we called this a prism plus a pyramid as far as volume was concerned. Now that seems like a fairly accurate description as far as surface area is concerned as well. So calling it a pyramid plus a rectangular prism is still accurate. Okay, the formula obviously is going to change since we're no longer looking for volume. Okay, so the formula for a pyramid's surface area was 1/2 times the perimeter of the base times the slant height plus the area of the base, 1/2 PS plus big B. Then when it came to the net of the prism, okay, we did not have a formula to go along with it, so we said that finding the area of surface area of a prism was to unfold the figure and consider the net. Okay. Now, as you probably can recall from the little cube activity that we did in class, we learned that when surface area is concerned with composite shapes, we often have 2 figures joining together. And when those 2 figures join together, they actually cancel out some of the sides. So in this particular instance, the fact that the pyramid and the prism have joined together, well, one side of the pyramid and one side of the prism have effectively canceled each other out where the figures joined together. So we would no longer want to consider those 2 sides to be part of the surface area. Okay, so the pyramid, we can see all of the triangular lateral faces are still exposed to the exterior of the figure, okay, but the base is caught in between the pyramid and the prism. So we would want to remove the base from the formula for the pyramid. Now on the rectangular prism, when it comes time to consider the net, if we assume that the square sides of the prism are the bases of the prism, then one of those squares is canceled out by the pyramid joining up against our prism. Okay, so we would want to consider only the lateral area of the pyramid, and then when it comes to looking at the rectangular prism, we're going to have to remove one of its bases. Okay. Now I want you to leave about 4 or 5 lines worth of space on your paper. We will work this out in class together. Okay. Now moving on, let's take a look at the next shape. This one was what we called a cylinder plus a cone when we were looking at the volume. Now, this still seems to be an accurate description when it comes down to the surface area. It is still a cylinder plus a cone. Now, of course, the formulas have changed because we're looking at surface area instead of volume. Okay, and the formula for the surface area of a cylinder, well, a cylinder is just a special kind of a prism. So that will be to unfold the figure and look at the net. And the cone is a special type of a pyramid. And the formula for that is 1/2 PS plus big B. Okay. But as the figures have been joined together, we have a couple of sides that are canceled out. Okay, so on the cylinder, one of the circular bases is lost where the cone came into play, and actually the base of the cone is lost where the cylinder is making contact with the cone. Okay, so to make some adjustments, we will need to remove one of the bases of the cylinder, and we will want to only consider the lateral area of the cone. Okay, so once again, leave about 4 or 5 spaces worth of room on your paper so that we can look at the calculations in class together. Okay. Now the next figure that we're looking at was the rectangular prisms. And for volume, we said that we had a large rectangular prism, and then we had a smaller rectangular prism that was removed away from that. Okay, so from a surface area standpoint, we have extra surface area that is provided by the fact that there is a rectangular prism that has been removed. We have some new surfaces that are exposed to the outside of the figure. Okay, so for volume, we said this was one rectangular prism minus another rectangular prism. But when it comes down to surface area, we're actually going to have to say that this is, should have said a rectangular prism, not a cube. Should say a rectangular prism plus another rectangular prism, because we have sides of both of them that are exposed to the outside of the figure. Okay, so when it comes down to our formula here, of course, we are looking at 2 rectangular prisms, and hopefully, yeah, I've got a cube formula in there. Sorry about that. Should say the net of one figure plus the net of the other. So both of those should say net instead of 6s squared. So for those of you that are not listening to the audio, I'm sure you will have the wrong things copied down on your notes. And then we're going to need to make some adjustments. Okay, so the adjustments are going to be for our large rectangular prism. Well, we have all of the information, or all of the sides are exposed to the surface area. However, we have 2 small rectangles that are going to be missing from this figure, both on the top and the bottom. Basically where this smaller rectangular prism kind of came out of this larger rectangular prism. Okay, and on the smaller rectangular prism, we have only the long sides that are traveling through our large prism. Only those long sides are going to be added in. As you can see, we have a gap running all the way through this large prism, so we do not actually get the bases. Okay, so we're going to have to say that with the larger rectangular prism, we're going to have to subtract those 2, and it should say rectangles. I apologize for all the errors here. Minus the 2 rectangles where the smaller prism exits. And then on the smaller rectangular prism, we're only going to be considering the lateral area. So if we're going to assume that the 2 rectangles at the top and the bottom, those are the bases, then we're only going to be looking at the lateral faces. Okay, leave a little space. We'll do the calculations in class. Hopefully I won't make so many errors doing the math of this figure when we get to class. Okay, now here was the next figure. Okay, in the calculations for volume, we said that this was a triangular prism plus a hemisphere. Okay, well, that's still an accurate description when it comes down to surface area. We have the majority of a triangular prism, and we have a hemisphere involved. Okay, so triangular prism plus hemisphere is a good description. Okay, so for the formula, again, with a prism, we will be considering the net of the figure. Okay, and the hemisphere, we have a formula for the surface area of an entire sphere. That would be 4 pi r squared, but with the hemisphere, we're only interested in half of that, so we would have half of 4 pi r squared. Okay, now we do have the entire hemisphere on the right side of that little problem, so we don't have to make any adjustments there. But the prism has part of its surface area being blocked where the hemisphere joined in. So we are going to have to remove that circle where the hemisphere is making contact with our prism. Leave a little bit of space there on your paper. And then lastly, we had this figure. When we were talking about a cube, talking about volume, we called this a cube minus a pyramid. However, with surface area, okay, the fact that some of our volume has been removed from the figure causes some extra surface area to show up. There are new sides that are exposed to the outside of the cube that would not have been there if the pyramid had actually been inside of this cube. Okay, so with our description, we're going to have to call this a cube plus a pyramid. And we do have a formula for the surface area of a cube. Each side is side squared, and of course there are 6 of them. And then our pyramid is 1/2 times the perimeter times the slant height plus the area of the base. Okay, as far as our adjustments are concerned, when we look at the cube, we have 5 of the 6 sides of the cube still intact, so we will need to remove one of them from the net. And then from our pyramid, we have all of the lateral faces, all the triangles from the sides of the pyramid, but we do not have its base. So we're going to have to take the base off of that formula and just look at the lateral area only. Okay. All right, so we're going to have a little bit of math, some calculations to do when we get to class, but these are more complicated than I want to work through with you on a video. Okay, so bring your notes with you, hopefully intact, to class, and we will go over the math together. I appreciate you finding time to get your notes taken care of, and I'll see you in class.